Okay, hello everyone. So let me take a few questions before we start. I guess you might have some questions about the midterm. So I'm going to post the solutions into your repo today. Like I'm going to clone all your answers and then push the solutions for this. So maybe by end of today or maximum of tomorrow, you will find the solutions of your version of the midterm in your repository. So the question is about if you answer things in the GitHub web page, you weren't able to run stuff. You might have some syntax errors. Is this going to penalize you much? No. Most of the grades are not in the syntax. They are more in the coding and the algorithm. But if you have some syntax errors, you might lose some kind of fractional or minor grades. Yeah. What else about the midterm? Code efficiency, if the implementation is correct, no. Code efficiency you are not going to get penalized. If the code is working as supposed to work, then it's okay. You are not penalized for time efficiency. Notation error, not sure what you mean by notation, but if you mean syntax errors, like you are missing a semicolon or something, that's okay. For Nicole, so I did delete them and they were deleted for some of the repositories. For some reason, I believe those who didn't push, and this is why I asked everyone to push any change he might have before I do the cloning, which I have done just directly before the midterm. This was one of the reasons of the delay. I wanted to wait until everyone pushes his changes. So those who didn't push their changes for the dummy test, they had conflicts. Yeah, Nicole, then I really don't know what happened because I did remove them from my end. That's interesting. I hope this didn't affect you. I guess what I said at the beginning of the exam is that if they don't get them deleted, just delete them yourself. So someone is commenting about the time. So about this, so I gave the time. So basically, whatever time it took at the beginning to get the push happening for everyone, I gave more than this time for everyone afterwards. So and to be honest, the original exam time was just 1 hour. I made it 1 hour and 15 minutes, also to account for any kind of errors kind of problems you might get with Get. So I'm not concerned at all about timing for this exam. Aaron, if you use recursion, well, we didn't cover recursion yet, but if it's a correct solution, I mean, you'll not get penalized for being advanced in programming, right? So don't worry about this if it works. I forgot to delete the demo file. Yeah, that's also okay. This is one thing also to comment about. So because maybe I'm not sure if I made this clear, but being able to run things in Eclipse and check your code was more of, I would say, a privilege or an advantage that you might have, but you're not required by any means to do so, right? So what I mean is, if you didn't want to check your code or bother at all about problems with Eclipse and just write the code as if you do it in a piece in a piece of paper, that's also completely okay, because from our end we're going to write to mark whatever you have wrote, right? But I thought it's good that now you have the ability to test your code because you are running in your own machine, not in a paper and pen setting. Yeah, so if I were you and I'm in the exam and I'm encountering so much problems with Eclipse, I would just go ahead and write on GitHub directly, right? And again, this is maybe a lesson for the final. I will wait until you guys get the answers and you get your midterm grades. I see what is the average, and then we can discuss what are the lessons we learn from this experience, right? I would say don't worry too much about grades. You probably will get them by next week, early next week. Ishmael, like the question waits, I'm going to post an announcement today. Once I push all the solutions, I will also add an announcement for the weights of the questions. For those that I received a couple of emails saying that we didn't know about this because we weren't in the meeting that you said you will be in, and we didn't hear that we have some extra time. I would say if you thought the exam is ending at 8, you would still had 1 hour, which is the original exam time. But if you weren't able to finish by this and your last comment was at 8, send me an email and we can see how your answers look like and how I can accommodate for this, right? Next time, I would recommend everyone, for example, in the final, to maybe we can do a mocking before the final, given even the final weight is more. So we can do a mock to make sure we all go through the process. And I guess the midterm will help us. The exam ended 8:20 because we gave extra 15 minutes because of the delay happened for some of you at the beginning. The delay was only 10 minutes maximum from my end, which means everyone got his answers, or maybe like between 10 and 15 minutes. So everyone got his questions before. It was supposed to be 6:40, but everyone got his questions before 6:53, if I remember the number exactly. And this is why I said, you know what? You have extra 15 minutes at the end. But if you didn't leverage this time, yeah, so I will try to, yeah, we will come up with a way, Karina, to make sure how we communicate through the exam. But posting announcement is one way of doing this for sure. That's okay, Ishmam. Yeah. Well, yeah, this 6:55 maybe because of the minute that you took to bowl, right? But as I said, I started counting from 7, so you wouldn't even bother. You would have extra 5 minutes as well. With those comments about the README, because I received a bunch of emails about this. If you didn't update the README file, don't worry too much, because we learned for Lab 0 and Lab 1 those kind of weird names you use for the Git repository, and we have a match, right? But also, if you want to push a change to the README, only the README, and you have done this after 8:20, that's also okay, as far as the change is only for the README, because something, again, good about GitHub is we have for every comment what files have changed, and then if we find that you only changed README, that's okay, right? So both are fine. So don't worry about the README at all, right? Okay. Is there any other concerns? I don't know. There is no midterm. The second midterm, it's just a single one, as in the outline. I guess we can discuss more once you get the grades and the answers. And I would also like to get your feedback whether you think the exam is easy or hard, but maybe better to do this after you get the answers and the grades. Okay. Karina, yes, the latest push allowed was before 8:20. That's correct. Yeah, as I was saying right now, you will get the grades early next week, maybe Monday or Tuesday, the latest. No, answers today, model answers today, just the answers, but the grades, I mean, they cannot finish in 12 hours, right? So yeah, early next week, Monday, Tuesday, the latest. No grades or no marks are lost for not adding comments. That's okay. Yeah, Moaz, that's also an excellent point. There is no one correct solution and everything else is wrong, because this is programming. So there might be, or in fact, in most cases, there are multiple solutions to the same problem. Don't worry about this. I'm just posting one possibility. Maybe in some questions, I'm posting 2 possibilities. But if your question is working, that's completely okay. Anthony, if you missed the midterm, you don't have to submit an MSAF. The weight moves directly to, as far as you didn't write the midterm, the weight moves directly to the final. Good. Okay, so again, I don't want you to worry too much about grades for this course. We can handle things together, especially in this kind of weird new environment. I know that you guys are suffering because of this. I'm also learning on my side. I'm trying to do my best, but as you can see, things can behave differently for the first time. So don't worry too much about grades for this course. As far as you are learning and you are gaining experience in programming, this is the intention, right? So I will wait and not make any comment about the midterm grades until I see the average. and then we can discuss, right? So I'm not worried, and you shouldn't be worried at all about grades. For lab questions, I would prefer to take them in office hours, or you just go to office hours with the TAs, and they can help you with this, Ishmim. And I would start in this very delayed lecture for pointers. And yeah, if there is any other question or concern about the midterm, don't hesitate to email me. Or if you want to wait until you see your grade and then we email, and that's also okay. Once I post the grades, you will have the model answer anyway, but if you want to discuss your grades with me, we can also arrange this through the office hours. I'm not sure, Jiao Yang, what you mean by notation. Forgetting to put notations. Do you mean comments or like semicolons? I'm not sure. Oh, semicolons. Yeah, well, that's a syntax error. And as I said, the weight on the syntax problems in your code is not that huge. You might lose like a mark or two maximum. So don't worry about this as far as your coding is correct. But just to, like, this is a general advice not related to the exam. If you forget to put any semicolon at all, not just a single one, that means you don't have enough experience coding with C by now, which you should have in lab 0 and lab 1 and lab 2, which is almost done. So forgetting semicolons in all lines is something kind of concerning, right? But yeah, but if you just forget one here and there, that's okay, don't worry. Okay. So I would like to thank you all, like for kind of going through this new experience or this new initiative using Get. I thought it's better than others. Avenue, for example, something we can discuss once you see your grades is, for example, something we can have we could have done if we wanted is we just forget about Eclipse at all, any Get pushes or whatever, and you write your exam directly on the Get browser, like your browser using your Get repository, right? If you want to do this for the final, we can discuss after the midterm. But this is something that will be good because you wouldn't have any problems with any environment. But from the other side, it's a little bit worse in the sense that you cannot test your code unless you just copy it and go somewhere, right? So I made this an option in the midterm. If you got problems, you can just write directly into the GitHub, and some of you have already done this. Some of you choose to go to Eclipse. So I'm flexible in that sense. I'm not obligating you to use Eclipse, and I'm not saying you cannot use Eclipse. You can use it to test your code. That's okay. I'm assuming you can do this. And at the same time, if you only want to write on Git and just finish, that's also okay, right? The final will be Java and C. So, but we'll discuss this once we approach the final exam. So don't worry about the final exam for now. Okay, good. So let me start with today's lecture and just review a little bit what we have went through. We have finished this, but maybe it's good to start refreshing our minds. It has been more than a week. So arrays of pointers, right? So we discussed pointers. We said that pointers are normal variables in C, except that what the value they hold is the address of another variable, right? And this is what makes them special, right? Now, if we want to define arrays of pointers, we know that the array name itself is a pointer to the first element. So here I'm defining an array of 3 pointers, which means you have 3 elements. Each one of them is a pointer to an integer specifically. And then if you define just 3 normal arrays A and B and C that holds these values, now something you can do is you make each element of this, for example, BB0, which is an integer pointer, points to the first element by assigning it to A. And then this one points to B, this one points to C. By doing this, maybe you don't realize this, but this is a basis of something you will see later in 2SI and other courses that is called a hash table, right? So you have an array that holds some key values, which here are the pointers. These key values are pointing to another data structure, which is here another array, right? So this, let me see, I just want to write. Okay, so yeah, so this one now is pointing to the data in this one, right? And hash tables are very, very common in almost all applications. Any machines you would find that have some kind of embedded processing will include, or even machine learning, or like social networks, whatever, they are using some sort of hashing to make the processing faster, right? Good. So now, if we want, for example, to access AJ, the easy way is we know that BB0 is replacing A because it's pointing to the first element of array A, and just saying AJ is equivalent to say BB0J, right? The same thing for BJ, you can see BB1 and then access J, and the same thing for C. Good. Now, given that we know that there are 4 different notations for accessing array elements in C by choosing the array name or the pointer, saying A1, sorry, which is here 2, this is A1, is equivalent to say BB0, which is pointing to the first element and then 1, or also equivalent to say dereferencing. BB0 is the address of the first element, add 1 into it, which means the address now is here, and then do a dereferencing to take the value, right? Good. And we have done all of this in the last lecture we discussed. Good. Another way of doing this, here we assigned each element separately, right? Another way of doing this is to say, now I'm declaring an array of pointers and I'm initializing it by the array names, ABC. This is also accepted. But what we said is not accepted is you initialize the values themselves. And the reason we said this is not possible, it's also not possible. I mean, we discussed it even in previous lectures. You cannot use a pointer to declare an array. And the reason for this is a pointer is pointing to a single integer value, which is 4 bytes, while the array might hold multiple values, right? So this is not allowed. Let me know if there are questions. I see a lot of things going on the chat. Okay, the last question is about lab. Ishmael will be the final. I guess I already addressed this. Everything afterwards is, I guess, like a side chat, so that's okay. So if you guys, again, like as normal, if you have questions, just use the question brackets and then I will look into those. Okay, arrays of strings. So why arrays of strings? Because as we said before, you have something, you can build arrays of this thing. And then we also know that strings are a special kind of arrays in C, which are arrays of characters, right? While you need to end them with a null character. Good. So here I'm defining an array of strings using pointers. And what you do here is by doing this, you make the first element of this, or the first pointer is pointing to the first string, the second one is the second string, and then third one, and then the fourth one, right? And then I guess we took also the example that we want to exchange 2 different values in your string. This sometimes this can be called like a dictionary of string values, and then accessing this dictionary. This is, again, I call this hashing. Just remember this name because you'll see it later, and then you use it to access a certain like chapter or a certain element in this dictionary of strings, right? You also see this a lot, like many string questions in interview kind questions if you are interested. So what if I want to swap certain elements? And swap, some of you already got the swap function in the exam. Simply what I would do is, here it's a little bit complex because each one of this is pointing to an array, which means it's a double pointer. And what we do here is we just exchange the values using the pointer notation, right? By doing this, we are moving the first one here to point to the last one, and the second one point to the last one, and then replace the last one, make it point to the second one. By doing this, you have easily exchanged them without moving the characters at all, right? Good. Something now to discuss that takes us to the topic that we want to discuss for the first time today, which is the array name of this pointer array, BB itself. We know that the array name is a pointer to the first element. The problem here is that our first element is a pointer on its own, which means BB is a pointer to a pointer, and we call this a double pointer, right? Or a pointer to a pointer, right? Which means BB is holding the address of BB0, and then BB is a double pointer. What is a double pointer? Simply, a double pointer is just a pointer. What is a pointer? A pointer is a variable that is holding the address of another variable, right? For example, an integer pointer is a pointer that is holding the address of an integer variable. A pointer to a pointer is no exception. It's a variable that is holding the address of another variable, but happens that this other variable is really a pointer on its own. So let's have an example to make sure we understand. Here I'm declaring a pointer that has a value of 100. I'm declaring an integer that has the value of 100. It's a normal integer variable. Then I move a little bit one step forward and declare a pointer that has this address. So simply here by declaring b, which is a pointer to an int, the address of a, which is this one, is placed in b, right? Now the third thing and the new thing is I'm declaring a pointer to b itself, and this has to be a double pointer. Why it has to be a double pointer? You can read it like this. What is this? This is a pointer to an int, right? I want bb to be what? A pointer to an int pointer, right? So here it's a pointer, and this is the int pointer, right? This is how you can understand why it's double pointer, right? Because it's a pointer to a pointer. And the way now we are assigning the address of b into this double pointer. So that means b now is pointing to bb is pointing to b, right? Good. Okay, perfect. So just to make sure we understand, you can dereference a double pointer. So dereferencing the double pointer once gives you the address of the pointer that it is like pointing to, which is b, right? Or in other words, the address of a. While dereferencing bb twice is referencing it once gives you b, and then dereferencing b is easy, we know this from before, gives you a value, right? So dereferencing a double pointer gives you the variable itself twice, while dereferencing it only once gives you the original pointer that is pointing to. Okay, time for questions. Questions. And Zauhan, we know the pointer also have address. If pointer points to an array, will this pointer address conflict with the number of address inside the array? The pointer also have address. That's correct. If pointer points to an array. So let me give you this example because it's important to understand. So the question is saying the following. I have, for example, array A, similar to what we had in previous slides. I make a pointer B that is pointing to that array, right? Which means it's holding like the same address as A0, right? Is the question that whether this address of B itself, which is something like 0xff, let's assume that 0xff is the address of B, while, for example, the first element here is 0x3. Good. That means the value of B is 0x3 that is stored inside 0xff, right? So these two are not conflicting. This is the value of B, while this is the address of B. If you want to access this, you have to make a double pointer, as we like similar to what we discussed right now. If you want to access this, this is simply B value, which is the address of A0, right?
Excuse me, but what about the second number in array?
The second element, A1, you mean?
Yeah, this address will conflict with the...
No, if you want to access A1, the way to do it is simply, okay, you know that B is pointing to A0, right? So just adding 1 into it is giving you the address of the first element, and dereferencing it gives you the value, right? Similar to what we discussed before. So this address, which is, if this is an int, if this is 3, you add 4 into it, so it gives you 7, right? So why you think this address of A1 is conflicting with B? Because B is stored in a completely different place than the array itself, right?
Oh.
Is that clear now?
Okay.
Yeah, thanks.
Thank you.
Welcome. Sarah. So the only way to access the address of a pointer is by assigning another pointer. Yeah, exactly, Sarah. That's correct. Yeah. Okay, good. So here is the example that we were discussing. We said BB is the address of the first element. That means if you dereference BB, it gives you BB0 or the address of A0, while dereferencing it twice gives you A0, right? Then if you say BBIJ, let's decompose this to make sure we understand. BBI is some element here. Let's say if this is BB1, that means it would be this one. And then J, it takes you to the J here, which in other words, if you say, let's look into an, okay, so maybe I would just write the example myself. If we say BB1 and then 2, BB1 is this, and then 0, 1, 2, this gives you this. So this is exactly BB1, 2. What are other ways of axing it? You can use dereferencing. I can dereference this array, this pointer. So saying BBI plus J is going to give me this address, and then I dereference it once. Or I can say, again, this is another array notation that I can replace with dereferencing. Right here, I did a single dereference. Here I do twice dereference. The general rule is any array indexing you can replace with a dereference, right? So BBI, you can replace it by BBI plus I and then dereference, and then overall you want to dereference the last address or the final address, right? So if we read this, I would say BBI plus I is element I in this array, the address of element I in this array. Dereferencing it gives you the element itself, which is here BB1. Adding J into this takes me to here, but this gives you only the address. If you want the value, you do another dereferencing. Good. These things you will understand only if you try them out. Like if you write them, you do a printf, you construct an array, you take one of the examples in the lecture and you write them down, right? And in lab 3, we go through this by the example of a linked list. So you will really understand what happens when we go there, right? Question from Michael. If we do something like AND B, can you access the address of your pointer? Yes, if you make AND B assigned to a double pointer, similar to what the example we have done in the previous slide, Michael. Here, what we have done here is we said AND B, which is the address of B, and we put it in a double pointer. Okay, let me see if there are other questions. Muaz, can you also do AND B for the first pointer? Yeah, this is, you mean, I guess, the double pointer itself? Yes, you can do it if you assign it to another pointer, right? Any pointer has an address which you can access if you define a pointer into it, right? Snigda, what would this and BB plus 1? You cannot say plus 1, 0, right? This one wouldn't happen, but I believe what you are referring to is if you do something like this. BB plus 1 and then 0, right? And then that, because in this thing you are saying BB plus 1 is equivalent to BB1. BB1, 0 is the first element in your array here, which is this one. Dereferencing it gives you 3, right? I would say, guys, try this down and then print if every one, and you will really get how it works, right? Okay, so now moving to 2D, like we covered dynamically allocated memory in previous lectures, but we have done this only for a 1D array. What if I want to dynamically allocate a memory for a 2D array? How to do this, right? So let's look into it together. There is no new information here. It's just applying what we have learned before, combining knowledge together just to exercise a new use case, right? So the first thing is there are multiple ways of looking into a 2D array. The first one is you have an array, and each element of this array is axing another array, right? This is one way of axing a 2D array, and this is what we had in previous slide, right? Good. By saying BBIJ, now you say I go to the element I here, and then go to the element J in that array, right? This is one way of representing a 2D array or a matrix in C. Good. How to write this down or how to allocate the memory for this? Simply, you first need to allocate the memory for this one, and then for each of these arrays, you have to allocate the memory separately. So here I'm writing like a code snippet where I'm asking the user to input M and N. You can think of M and N as the number of columns and rows of the 2D array. And then I allocate. Here I'm allocating, assume this is a float, like a 2D array of floats. Then I'm saying, okay, allocate to me a memory size of M size of float pointer. What does it mean? Remember that we said size of gives you the number of bytes of this certain type, right? And you can give it any type, and we said also you can give it a pointer. Float pointer is just the address, which in some cases is 4 bytes or 8 bytes, so it gives you the size of a pointer. by doing this, you are allocating these m elements. Each one of them can hold a float pointer, right? But you didn't allocate any of that yet, right? To do this, you have to do a for loop over each element here, going from 1 to m or 0 to m minus 1, and then allocate the other array, which every one of them has a size of n, and this is this n, and it contains floats, right? So the first one is the pointer to the other arrays. This is why each element here is a float pointer, while each element of the second array or the second list of arrays is float, right? So this is one way of doing it. If you got questions in this example, please ask, right? Because we will see other alternatives here. Question, can you do, I said this, Nida, I already, and Ishmam, will you cover triple and quad pointers? Well, no, but there is no big difference. So if you think of a pointer to a pointer to a pointer, we can discuss this in an office hour, right? But effectively, what is a pointer to a pointer to a pointer? You don't really care about the last one. So if your pointer is pointing to a pointer, then it's a double pointer. What this second pointer is pointing to, whether it's a pointer or not, it doesn't really matter, right? And usually people don't go beyond like 2 pointers. So I would say, let's discuss this through office hours. What you need to know only is just the double pointer, right? Why do you use malloc twice? Yeah, that's an important question, and Aman again as well. That's also an important question. Let me quickly repeat the rationale behind this. I need to allocate. This is a 2D array, and we kind of together agreed the way to structure this is to have one array, and each element of this array is pointing to another array. This is how you can declare a 2D array, right? And one way of doing it. So that means now you need to allocate this array, and you need to allocate each of this array, right? So you need to allocate this and this, right? The first one is allocating this pointer array, right? This is why it takes a size of float pointer and it has m of them. While the second one, which is inside the for loop, here we have n of those. M of those, right? Because each m is pointing to a certain one, and each one of them has n elements, right? This is why we loop through m, and each time we allocate n elements, right? This is why I use malloc twice, right? And size of float, this is a float pointer. We said here, this is the pointer array, which means each element has a pointer, and it's of type float pointer. That means you need, the way you use malloc is to specify the total size. You have m elements. Each one of them is a float pointer. So you get its size by using size of. Good. Let me just check the time, I guess. Okay, good. So a second way of doing it. So a second way of looking into it, instead of just defining this as separate arrays, remember we said you can represent a matrix, and you have gone through this in lab 1 as well. You can allocate a matrix using just one array, right? And we have gone through some examples of this when we discussed 2D arrays, right? To do this is another way of doing it. And instead of just defining these m arrays, you have only one of them, and then you put the elements side by side. Now what you want to do is you want the first element to point here. Can someone tell me where I want the second element to point? Just to resemble what we had in the previous slide. PB plus 1. PB plus 1 is this one, yeah, but where it goes, like, yeah, so I just got it. So it goes after n, right? So it's n plus 1. Because this was the first array in the previous slide. N plus 1 to here, which is n plus 1 plus n, which is 2n plus 1, is the second array, and then 2n plus 2 is third array, etc., 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 right? So you want them to point, and the last pointer is pointing to the last n elements, right? So, okay, this is the structure. How is this different from the previous one? The only difference is previously here, you needed to allocate how many arrays? You need to allocate m of them, and each one of them is size n, right? Now, how many arrays I need to allocate? It's only one, but it's of larger size, right? So can someone tell me what is the size of this array if it resembles all these arrays together? If you have here an m by n matrix, which is a 2D array, you want to represent it in a single array, what would be the size of this array? It's m by n, Danny. That's exactly correct. So you have m by n array that you need to allocate. So now you would be allocating two arrays. The first one is the regular one, which is the pointer array. The second one is not inside a for loop because it's a single array, but now it's size m multiplied by n elements. Each one of them is a float. It remains to make the pointers point to each of specified element. So now you say from I to m, each of these pointers, make PBI point to q, which is the pointer that is allocated, that is returned by this malloc, which is this one. Remember, malloc is returning a pointer to the first element, so this is q. And then each time you need to increase by I. So the first one is pointing to 0, the second one is pointing to n, the third one is pointing to 2n, 3n, etc., etc., right? Is there any question in this example? Yeah, that's a good question from Arjun. Is the memory allocated from malloc from each array in consecutive position, even though they are in separate arrays? That's an excellent comment, Arjun, that we will make towards the end. After we cover all the examples, we will see what really are the differences in what's going on between the different examples we discussed, right? So I would say hold on this question until we come into it. Muaz, why is BB a double pointer but Q is a single? Okay, that's also a good question, Muaz. So Muaz's question is, why this one is a double pointer while this one is a single pointer? To answer this question, look into what data the pointer is pointing to. What is the type of each entry here in this array? It's float, right? So it's a regular float, which means Q is a single pointer because it's a pointer of a float. What is each element here? As you can see, this one is pointing to Q. So each element here is a pointer of type float, which means BB itself is a pointer to a pointer, right? So this is an array of pointers. This is an array of floats. Another way to understand this is the array of pointers is holding the addresses of the arrays of floats, right? So you store the addresses in one array and the actual elements in other multiple arrays or a single array that is consecutive to each other, right? So going back to the previous example, the only difference is, again, this is still an array of pointers, which is holding addresses. And this 2D matrix is holding the values, right? Remember when I told you that this is some kind of hashing where you have a key and value, right? You have an address and data, right? Address is stored in the array of pointers. The actual data of floats is stored in these multiple arrays. Good? Okay, a third example, and then we will stop and try to compare all the three to answer multiple questions, including Arjun's ones. So here, what if, is it possible to, now we moved from, we have one array of addresses and multiple m arrays of data, and then we moved forward by saying I can have a single array of data consecutive to each other. Can we have everything in just a single array, right? It's a bit complex, but it's good to understand, right? So how can I do this? You can simply, instead of defining n like those m by n elements, you can use the first part of your array to store the addresses, the pointers, right? So how to do this? What you would say is, okay, let me now say I have now a single pointer, so you don't store these separate addresses somewhere, and then I'm allocating the total of this array, which is exactly the same as the previous data one, but now I don't store the addresses somewhere. And what I do is, the problem happens when you try to access these. What if you want to access these? Now you cannot use this 2D or matrix notation. You have only to use a single notation because now it's a single array. Is this easy? Yes, you need some kind of math calculation to represent a 2D indices into a single one. For example, if you want to access element I, j, what you want to say is you can still access, you know that I, you go to I, what is I? I is the number of the array itself, let's say 2. So this is the second array, this is 0, 1, 2. And then j inside it. But how to go inside j inside it? You know that each one of the I is n, so this is shifted by n multiplied by j, right? This is the hardest one to see or grasp because it's a little bit counterintuitive, but simply you are putting everything in a single array and you need to hope each time you want to access certain row, you need to add to multiply by n because you know that a single row is n elements, right?
I think it's n times I plus j.
Oh, it is. Yeah, sorry. It's my bad. That's correct. Because that's correct. So if we say B2, here you want to say, I want to access the j element in the second array after like 0, 1, 2, but the second array really is a virtual thing. It does not exist. So the way to go there to the first element of this second array is to multiply I by n. So it's 2 by n. I would guess if we have an example, let's say n is 3, right? So if you have n is 3, then the second one starts and 0, 1, 2. This one starts as 3, and then it goes up to 7. And then the third one, 8 to 11, right? So if I want to access, for example, B2, 3, the way to get this is you want the second row, but you know that the second row is starting from a certain index. This index, the way to get it is to multiply I by n, because you know that each one of them is 3 elements. So it's multiplying I by n is, oh, I'm missing something, 0, 1, 2, 3, 4, 5, and then this should be 5, and this should be 6, 6, 7, 8 to 8, right? So you multiply this by n is 3 here, so 2 multiplied by 3 is 6. So it is going to be B6, but B6 gets you only to the first element of this segment, and then you want to add 3 into it, but because we have only 3 elements, this, let's say 1, right? So you just add 1, which takes you to B7. Effectively, B7 is really B21, right? In the original 2D matrix, right? So something I usually like was asking this as a quiz during the lecture for an exercise, ask you to implement like the 3 and look into the output to see how every element is mapped to the other. But I would say take this as an exercise you can do when you study this lecture by implementing the 3 and then print and out, like take a single array and then feed it to all, like implement it using the 3 different ways and then print it out, look into the output, see how the elements map to each other, right? Good. So, okay, we have 8 minutes. I would say, let me stop and make some conclusions about these 3 examples. What are the differences? What really are the differences between this? First of all, from the functionality point of view, they are all the same, right? You are defining a 2D array. You have some data structure in the background, in the memory, to resemble this. This data structure is different, but at the end, you can access the elements as if you have a 2D array, right? Whether you do use a 2 subscript or a single subscript, it doesn't really matter. So then what is really the difference, right? So can someone point some differences that are happening? Then setting q equal clock and multiplied in size give the same result. Yes, that's correct. Yeah. So what you might expect that the differences between this, right? So first of all, let's think about how many malloc or how many allocations I have done, right? And this takes us to Arjun's question. In this example, I'm doing this, if we go forward, I'm doing every, it became a mess, but I'm doing every one of these allocations in a separate line, right? So I have here m different mallocs, right? Because I have done these m mallocs in separate instructions, in separate lines of code, they are independent of each other, right? Which means this array is stored in a memory that might not be consecutive, not necessarily consecutive to this one, right? So every one of this can start from a completely different place in memory. Why? Because it's a separate malloc, right? So whatever you have free in your memory, you will use it. Is there an advantage for this? What do you think might be the advantage of this? Contiguous is yeah, okay. So contiguous means consecutive to each other in memory. It's a kind of an academic term that we use always in papers, but sorry for that. So it's means consecutive in memory, like the addresses are back to back, right? So they have localities, they are beside each other, right? Oh, Daniel, that's perfect. Yeah, that's usually I would give some bonus marks for this, right? So what he's saying is by allocating them separately is if you don't have enough memory in your RAM, for example, you have fragmented memory spaces. For example, assume this is already used, this is empty, this one is used, but this one is empty. If you need to store all the m multiplied by n locations, but this is a small one, it cannot take all of them, then the second one will fail, or the third one even will fail. But this one might get through. You can get the allocation correctly. Why? Because you can store the first array here, the second array here, the third array somewhere else, right? So those arrays, given that they're not consecutive, yeah, not contiguous. Consecutive in memory means you have the flexibility to put them anywhere in the memory as far as a single array fits, right? While in the other examples here, you do a single malloc, right? To store everything of the m multiplied by n floats, this one, which means you need really a space of memory that has, if assuming a float is how many bytes is, let's say 8 bytes, you need this free consecutive places of memory to be able for the malloc to succeed. Okay, let me ask you, what happens if we don't have this space in memory? If we don't have such free space, what might happen? I will come into your question, Cham, towards the end. So what would happen if this malloc fails? This line, like, I mean, you don't have space in memory to allocate this full thing. Yeah, it returns null. Perfect. So that means your program will not succeed, right? So just to say it in other words, in some scenarios in your memory, the first implementation might succeed while the second one will not, right? Because you don't have a big chunk of memory free, but you might have fragmented chunks that can take the full array, but you cannot leverage using this single malloc, right? And the third one also applies to this. Okay, good. Then let me ask you, if the first one has this good example, what is bad with the first one? So this was the advantage of the first one, is it's flexible when you have a fragmented memory. What are the disadvantages of the first implementation, which is this one? Do you see any disadvantage? Oh, harder to index. I mean, this one is easiest to index because you already know you can just use IJ. The last one is the hardest to index, right? Because you need to do some math to obtain the index, right? Karina, you're saying overflow. So why overflow? If one fail, all fail, but that might be an advantage, Zawhan. You are correct, but this might be an advantage because you can check, you do a check. If the first one fails, you don't even try the other ones, right? So it's not really a disadvantage, right? You have to free separately, Sarah. That's a perfect answer. This is one of the disadvantages, but this is not the biggest one. No boundary checking exists for everyone, Yuvraj, right? It applies to everyone. Slower performance, exactly, Arjun. Why? Because these things, its advantage is really its disadvantage, right? It's flexible, which means, as I said, arrays get stored in different locations. But because, let's redraw what we had before. The first array is here, the second one is here, the third one is here, etc. Those things are not back-to-back in memory, they are not consecutive in memory, which means hopping between these arrays. So usually the way you access your memory, and you'll know this more when you go to digital design and other courses, if you access your memory in a consecutive way, it becomes much easier and faster because you have caches, you have locality, and things get smoother, right? But if you access your memory in a randomized fashion, or you keep hopping across different places, it takes more time, right? And which means this one has worse performance than others. in case you have enough space to allocate all of that, right? This is a disadvantage. Would moving around in memory be an issue with solid state memory as opposite to an? Yeah, Daniel, that's, yeah, it's still a problem, because at the end, it's not just the disk. I mean, the closest to your processor is the DRAM and the caches, right? And the DRAM, if things are not consecutive, they are still slower than accesses that are back to back, right? Karina, so our example 2 is faster or slower. Okay, so just to simplify this. Oh, sorry, this, I was talking about the first one. This one is, I was talking about this, like this multiple arrays, right? This figure here. This one is the slower, right? The second one, okay, maybe I have drawn the figure in the wrong slide. Sorry for that. But here you allocate just a single array, right? Using a single malloc, which is this malloc, right? This one, which means all of these addresses are back to back in memory. If you start from 0x0, you end up adding, like, if this floats 8 bytes, then 0x8, 16, 24, 32, etc., until you finish, right? So this one array is back to back, which means accessing it is much faster than accessing different arrays, right? I think we have gone beyond time. Oh, wow, we are good. Okay, that's what I thought. Yeah, thanks, Karina. Yeah, it was my mistake. Good. So just understanding these 3 examples, let's put something together to see what happens here. The only change in this slide from previous slides is a little bit more complete. It's a complete function where you allocated 2G, and you need to check whether your malloc succeeds or not. Here we are using calloc, but it's the same thing. I mean, because someone asked me about calloc, you can see it here, right? So let me ask the following question: which method? I hope this is not ready. Oh, it's already written. Okay, so we are using the first variant, right? So like the very first implementation, which is allocating different arrays for the floats, right? So how do we do this? First of all, you do a single calloc for the first array of the addresses, which are the pointers here. It's a float pointer, and then you go through these array element by element, and then you do the calloc. Here we use calloc, but it's exactly the same as malloc for the previous example, so you can check both. What we are doing here is, instead of basically we are putting the calloc. This is one more complication, and we'll stop by this example. We are putting the calloc result inside an if condition, right? What does it mean? It means we are checking whether the calloc has a null or not, because if null is equivalent to if false, which means the process didn't succeed. So if you fail, then you say, okay, there is no enough memory, and then you just return, right? Here I'm returning a null, right? But if it succeeds, then it goes through, and the buff takes the address of the first element, right? Here we are defining buff as a double pointer, because as we said before, this array is array of addresses or array of pointers, right? Which means buff, which is the name of the array, is a double pointer, right? And then later, for each element, I'm doing buff I, allocating it to the n elements here, right? So this is n, and this is m, right? Again, checking if it succeeds. If it's not null, then if buff equal calloc. So if it's not null, we should be good. Otherwise, we succeed, right? And then here we check. If you have an error, that's something that is very important to understand, right? If the process fails, and this might be another disadvantage of the first example. So here we break, but once we reach here, it means that the first array of the addresses is already allocated, right? Assume going through the following steps. I allocate the array of addresses, it succeeds, perfect. And then I start allocating the floats arrays. Oh, I hit the first one, I discover it fails. Or maybe in the fourth one, it fails, right? Because I allocated 1, 2, 3, 4, 5, 6 arrays. And then in the 7th one, I discovered I have no more space. one extra step you need to do. What is that? Can someone highlight what I need to do? It's not just enough to return null and stop, right? You got too many brackets on your first if statement. Michael, I will revisit this. So our example 2 is fast. Okay, so can someone highlight if you were able to allocate the array of the addresses and some of your data arrays, but you hit at a certain point in your for loop, you have no more space. What would happen? Now the previous allocation succeeded, the subsequent one are failing, so you need to stop. But if you just return, can someone see a problem with this? If you just print not enough memory, Karina, I mean, is that enough? You have to free, exactly, Ali, right? Because basically, if I allocated half of the arrays, not the other half, if I just return and print no enough memory, you will still have the malloc. Any malloc you do and succeeds, the memory will not get freed for you. You have to free it yourself, right? And this is the extra code that we have here. We say if you got an error somewhere in the for loop, you go through the for loop one by one, and if your buff is not null, which means the memory is succeeded here, this array has been allocated, then you have to free it, right? Then you do a free, and then you send the pointer name, right? So is that clear? So we do this block of code to make sure we free whatever memory we allocated if the whole process didn't succeed, right? Please ask if you got questions. I know it's over time, but I'm done with this. So you guys are free to leave unless you have questions. And I will stop here and take questions about this example. Yeah, because I mean, if it's a null pointer, it's not allocated at the first place argument, right? So you don't have to free, right? It's not even there, right? Arian, what does the last line do? Yeah, the last line here is saying, okay, after freeing all of this and freeing this, you have to free the buff I itself, which means you are freeing everything allocated to it. You still have the array of the addresses allocated, right? So the for loop is freeing those, the ones that were succeeding, but you still have this one, right? How to free this one? This one is allocated using this calloc. Its pointer is buff. So you have to use free buff to delete this one, right? And then you just make buff equal null because you return null, right? Vinay, it's a little bit different. So float. So basically, the example you have here is saying, please define for me an array of float pointers, right? We know that there are two ways of doing arrays. One of them is the way that you have, which is defining the array and its type. The other one is defining the pointer, right? And we have discussed, I guess, at the beginning of this lecture and in the previous lecture, what is really the difference between using the pointers for the array and defining the array or declaring the array as usual, right? So if you do this now, you would be having a fixed or statically allocated memory because you just define a certain array, right? It's not dynamically allocated. You cannot dynamically allocate buff in your example, right? Because it's not a single point, it's not just a pointer, it's really an array of pointers that you have statically allocated, right? Yanhao, for example 2, what does the last line do? Example 2, do you mean, Yanhao, this one? Let me see. Here? So this is the one that you are referring to?
Yes, exactly.
Okay, so if this is the one, this is going to, so now you have all your data in single array, you still need to access a certain element, right? So what you can do is you would say you want bi, for example, this one, b1, to point here. But what is this? This is if the array itself name is q, which is pointing to the first element, this one is going to be q plus n, correct? And the second one here after n is q plus 2n. So you need to calculate the start of each of the rows in your array, which is done through this line, right? For example, b1 is pointing to q plus n because I is 1. b2 is going to point to q plus 2n, which is the one afterwards, etc., etc., etc. Right?
But you have PP is actually pointing to a float pointer.
Yeah, yes, that's correct. But BBI itself is a pointer to a float. Here we're using BBI, right? Not BB. BBI is a certain element here, which is a pointer to a float, right? Correct? BB is a pointer to a pointer, which is the array name, but each element of the array is a pointer to a float, correct? So it's not a double pointer, it's a pointer to a float variable. It's a single pointer, right?
Okay, I see. Oh, I see. Thank you.
Okay, thanks. Oh, Alan, you have to do it. You have to do it using free. If you use any malloc, and that's one of the bad things about not being professional in C programming and using dynamically allocated memory. You might think that if you close your application, things get freed for you, but that's not correct, right? Your memory stays allocated for you there because you didn't free it, and that's bad. Sometimes your system will crash because you allocated too many memory for that, or too much memory for that, right? So I would say you have to free your memory. That's one of the most common mistakes for, I would say, hobby programmers in C. Marissa, if you define a void pointer and then want it to point to another pointer, is this allowed since void pointers are only defined with one? I guess you can assign the void pointer to any other pointer, but void pointer cannot point to anything, right? It's void pointer is a special pointer, which means you can take it. So for example, just to make sure, okay, here I'm defining a void pointer B. And then, yes, P can point to anything. If I'm getting your question correctly, what you're saying is, can I make P point to a pointer? I'm not sure of this, to be honest. I need to try it, because here you say it's a single pointer, but void make it a little bit generic. I need to check it. I don't have the answer on top of my head, but that's an excellent question. Katie, why do you free buff I then also buff? Okay, so freeing buff, that's a question that I was expecting. So thanks for asking. Freeing buff I is look into how the elements of the array here are defined, right? Here. This is the memory that you'd have, right? Buff I, or here is BBI, is pointing to a certain memory using the malloc. So if you, for example, here, if I free BB1, you are removing this memory, right? You are freeing it, correct? And you do the same thing across the loop from 0 to M, so you free everything of here. But you still have this array allocated. It's not freed, right? How to free this one? This one is defined using this malloc, which its pointer is BB. This is why we do free buff at the end, right? I hope this answers your question. Okay, perfect. So I question, why do we need to free buff if the array is not allocated? So here we assume, okay, that's a good point. So let's go back to the example. So the question is, why do I need to free buff if the array is not allocated? If you come here at this line of code, that means your addressee's array is really allocated, right? Because if it's not allocated, you would return from the beginning, right? So here, this block of code is allocating the buff array, which is the addressees, right? So once you reach it here, you means you were already successful allocating the buff array, right? Otherwise, you would have already returned, right? Nothing is allocated, null, done, right? You don't even need to free anything because the first array is not even allocated. But once you reach this line, this implies that your array of addresses, which is pointed to by buff, is allocated. But what is not allocated is some of the data arrays themselves, which are failing here in a certain loop index, right?
Quick question.
Yeah.
If you free the array of pointers before you free the arrays that contain the data themselves, do you then lose access to that memory?
Correct. Correct.
So that's like dangerous for the system,
That's
right?
very dangerous. That's correct. That's
Okay,
also why
so
we, yeah,
you always want to free the interior arrays first before you
correct.
free the
Yeah,
array of pointers.
yeah, that's completely correct. Assume that you have a database where you have keys and values, and then keys are the ones that you use to access the columns of the database. If you lose the keys, you are done. You don't have any access to the database. If you want to delete this database, you might need to delete all the data first and then get rid of the keys, correct?
Right.
Yeah, that's exactly the
Okay.
case. Perfect.
Right. So
yeah,
like basically if you were to delete that array, that you've basically just voided all that memory. Like you can't access that memory
you cannot
again.
access, but it's still there, so you are
Right.
wasting memory, right? Yeah.
Okay. All right.
Yeah, thanks, Arj. So there
Thank
was
you.
a question why I assign buff equal to null, because at the end you want to return null if the process didn't succeed. This is how this function works. And buff was the pointer that is pointing to all the addressees, right? This is the one that I'm returning. If it's not allocated, I'm returning null. If it's allocated and then the data is not succeeded and then I free everything, I need also to return buff. So I null it and then return buff, right? Good.
Like after you free it, does you still have the access of the buff?
Yeah, because buff is a pointer that is defined separately from the memory. So that's also a good question. So we need to differentiate between two different things. The memory that is allocated by malloc or calloc and the buff variable itself, which is pointing into it. This is outside of this memory, right? This is stored somewhere else, right? Because you already, this is allocated by this declaration, right? So for example, this memory can start from 0xf. This is in exactly like in a completely different place, right? Because you define it even before doing the malloc. So if you free this, the buff itself is not, I mean, wasted. It's just pointing to null, right?
I see.
Or you have to make it point to null just to right?
That makes sense.
Come. If you free it, then you just destroy that, right? So let me think. Does it override the pointer itself? I don't think so, to be honest. I believe it just destroys the memory. But because this memory is just getting destroyed, it doesn't mean it's null, right? It's like the value itself might contain garbage there. So your buff might still point to it, right? So I would say it's not necessarily a null, and then maybe it's safer to make it null. That said, sometimes I believe it just get happened by the compiler by default, right? Like you don't need to free it and then it works, right? For example, here, we didn't make these things null, but we free it afterwards so we don't lose it, because really you don't carry. Otherwise, at the end, you are going to free it, right? Okay, Ola, what would you change if the arrays are not all the same? Oh yeah, that's a complex question. Good. So if the arrays are not the same size, you wouldn't have a single loop to allocate them. You would have to allocate them separately unless you have a mathematical relationship where you can come up with an optimization for the code, right? But you cannot just simply use the malloc with the same size for every one of them, right? And that's a kind of a little bit building on top of this question. If you want to complicate the question, you can think of what if they are not the same size. For example, you'd say the first one element, 2 element, 3 element, 4 elements. How to do that? There is a way to do this through a loop, for example. You can come up with an algorithm if you think about that. Okay, good. So I would stop here, and then I would talk to you on Friday then, tutorial and the lecture. Thanks everyone, and have a great day. Bye-bye.
Hi, sorry. Oh,
Yeah.
just a question. So if this one is a none, so that's also mean I can free it, but it's useless. Is that right?
You free it. So you can only use the free function with the dynamically allocated memory, not with normal variables, right? Are you referring to the pointer, or are you referring to the memory that you dynamically allocated?
Because the last one you just told us, you just write if this one is.
Yeah, which one are you referring to?
Yeah, the last one you said if the buff isn't none, so you free it. So can I just don't write this one and I just free everything?
So you mean, for example, don't write this one?
No, the last, the things before, if this one, if buff I isn't none, now.
If buff is not null, you need to free it's the memory that is pointing to, right? So free buff is not deleting buff. It's freeing the memory that buff is pointing to, which is allocated using malloc or calloc, right? So this free buff is freeing this memory. Freeing means what? Means take it from your ownership of the program and give it to everyone else. It's a free memory that anyone can use, right?
Sorry, I mean, is whatever the buff I is now or not.
Oh, it doesn't matter.
I
That's
just,
correct. Yeah, because you will free it here.
But-
That's correct.
No, but I can do it, but it just waste calculation space.
Ah, that's
Is
correct.
that
Ah,
right?
yeah. So I guess your point is if you see here and then come say buff I equal null. Is that correct?
No, I just want to free buff I, whatever it is now or not.
Yeah, but this is what we are doing.
And I just
see. I see what you are saying. Let me think. Would you be able to send the free function a null pointer? No, it will not accept that. It has to be a valid pointer to a memory that you dynamically allocate. So free will not accept a null pointer.
so it give me error.
Yeah, it will give you an error. That's correct.
Okay.
Yeah. Yeah.
Thank you.
Welcome. Have a great day.
Bye.
Bye-bye.
Thank you.